Welcome to all in this my YouTube channel. Now we are looking at our chapter, that is solutions. Now in our last lecture we have seen Raoults law and some colligative properties. In that colligative properties we are in the first type of colligative property, that is lowering of vapor pressure. In that lowering of vapor pressure concept, the next concept is Raoults law for solution of non-volatile solutes. Now in our last video lecture we have seen the Raoults law. In continuation with that lecture we will see this point in our today's lecture. Okay. Now for non-volatile solutes we will see in details by applying Raoults law. Now what is meant by non-volatile solutes? First we will understand that, then we will go in detail. Now for solution the two components are very important. For example, solvent and solute. These are the two important components for solution. Now what is meant by non-volatile solute? Solute is one of the component of that solution which has no vapor pressure, and that non-volatile solute when we are adding in a solution, then its vapor pressure gets lower, and that point we will go in detail. Now here, when non-volatile solute added in volatile solvent, the vapor pressure of solvent over the solution is equal to the vapor pressure of pure solvent. Now that theory part or that statement we will see in the form of equation, and here which is multiplied by the mole fraction of solution, that is x1. P1 is nothing but what? Non-volatile solute when added in a volatile solvent, the vapor pressure of solvent is nothing but P1 over the solution is equal to the vapor pressure of pure component, that is P10 is nothing but what we can say, it is nothing but the vapor pressure of pure solvent, and multiplied by the mole fraction of the solution, that is x1. In solution there are two types of components are present, that is x1 and x2, that is mole fraction of solvent and mole fraction of solute. And here we have taken that equation, that is this statement we have converted in the form of equation, and this equation we are calling as the equation number 1. Now here after this concept which we can also see or look in this form, that is in the graphical form. Here if mole fraction increases, then the vapor pressure of solvent also increases. It shows the parallel relation, means with the increase of this mole fraction, vapor pressure of solvent also increases, as this dotted lines they shows that there is a direct relationship between both of these components, and here we have shown with the help of graph. Now for binary solutions, we can say that mole fraction of the two components, that is x1 plus x2 is equal to 1, and if we are going to rearrange this equation in the form of x1, we will get this x1 is equal to 1 minus x2, and we have substituted this value in this above equation, then we are getting p1 is equal to p10 in bracket 1 minus x2, and if we are going on multiplication of this term, that is p10 inside the bracket, then we will get this equation. Now after this equation we have modified this equation. In modification what we did, this term, that is p1 is having plus sign, and when I take it to the right hand side it will become minus p1. So here p10 minus p1, and what we did, minus p10 x2, this term is having minus sign here, and if I take all this term to the left hand side, it becomes p10 plus p10 x2. Okay, and I have called this as the equation number 2. And after this term, that is P10 minus P1, I have substituted as it is, and this change, that is P10 minus P1, is called as a delta P. So this point we have already seen in lowering of vapor pressure, that is in our last video lecture we have seen this equation. And here this delta P, if the value of P10 minus P is delta P, I will substitute this value in the above equation, then I will get this equation, that is delta P, also we can also call it as a P10 X2. Now in the form of X2 we have got this equation, and this is very important, and this equation I have called it as equation number 3. This is nothing but the equation of lowering of vapor pressure, that is delta P. Now this equation is helpful for determining the relative lowering of vapor pressure and molar mass, its relation with molar mass, that is these two equations. For that two equations, this equation will helpful. Now we will see the next point, that is relative lowering of vapor pressure. Relative lowering of vapor pressure is nothing but that term in which to lowering of vapor pressure you just go on dividing with the equation, that is the term P10. P10 is that term, it is nothing but the vapor pressure of pure solvent. So what I did here, I know the value of delta P, it is nothing but P10 minus P1. We already derived this equation. Only what you have to do here, you have to go on dividing on both sides by P10. Then this equation becomes relative lowering of vapor pressure. Related to pure solvent we have taken. Therefore this equation is called, we are calling it as a relative lowering of vapor pressure. So this equation I have shown there, and delta P upon P10 we can also call it as a X2. Why that term is introduced there? If you are going to just look at here, we have modified this equation 3 so as we can get the equation 4 there. How we have modified this equation? Just look at here. Delta P upon P10 is equal to X2. What we did? This P10 we have taken here at the left hand side. It becomes the denominator of that term. Then this is nothing but the value of what we can say X2. And this is nothing but what we can say delta P upon P10. And I have called that as equation number 4. Now after that equation number 4, we will move to the next point, and that equation number 4, what it indicates, it is nothing but what we can say the relative lowering of vapor pressure. Okay. After that equation, what we have to show here, molar mass of solute from vapor pressure lowering. In our old syllabus this point is there, but some modifications are made in this title. In our old syllabus the point is mentioned like this: relationship between molar mass of solute and lowering of vapor pressure, like that they asked. But here the meaning is also same, but the title is changed. Molar mass of solute from vapor pressure lowering. Means what here we have to do here, only we have to show the relationship between molar mass of solute, that we are calling it as a M2, and its relation with lowering of vapor pressure. That relation we have to show here, and this question may be asked in your theory exam for 2 marks. And this is a very important point according to the numericals, and some numericals also will be asked on this point. So you just keep in mind by keeping all these things in mind, we have to derive this equation. Now look at this point. What we know, you just write first. We know that this relation, that is relative lowering of vapor pressure, is nothing but the mole fraction of solute. As in equation 4 we have mentioned this value. And what is meant by X2? We already knows that that is mole fraction of solute, is nothing but the number of moles of solute divided by the total number of moles of two components present in solution, that is N1 plus N2. And for determination of value of N, what you have to do here, whether that considered solution may be dilute or concentrated, that you have to first look into account. Now here for dilute solutions we are determining. For dilute solutions what happens? The number of moles of solvent are more in number than that of the solute. Why? As we have called that solution as a dilute solution, so for that purpose N1 value is maximum than that of the N2 value. In that case, number of moles of solute are in very less amount, so the value of N1 will be more. And here also we have written, and the total, if the N1 is more has more value, then what about the total number of moles? In total number of moles, the value of N1 is also more. So it becomes like this: N1 plus N2 is nearly equal to the value of N1, because N2 is very less quantity. So here X2 becomes N2 upon N1. As we know that the mole fraction of X2 we will write like this, that is N2 upon N1 plus N2. In this case what we did, the value of N2 is when it becomes small for dilute solutions, then only these two terms are remain in that equation, that is N2 upon N1, and that we have written here, that is X2 is equal to N1 plus N2 divided by N1. And by understanding that term, we will move to the next point, that is next part of this equation. Now what the next term will becomes like this: delta P upon P10 is nothing but the relative lowering of vapor pressure, and is nothing but what we can say mole fraction of solute. That is we have arranged that equation in this form, that is X2 is equal to N2 divided by N1. We have substituted that value here, and after that what we did, N2 is equal to and N1 is equal to value we have substituted in that above equation. As you know that number of moles, its definition is nothing but N is equal to W upon M, that is weight of, that is W upon M in the sense mass of that component divided by its molar mass is nothing but what we can say number of moles. And here we have substituted its corresponding values, that is N2 value and N1 value we have substituted in this above equation, so as we will get this modified equation. And here this value we have rearranged in this equation, in the next equation. What we did, the denominator term M2 will multiply here, and denominator of denominator term goes to the numerator. So after rearranging this equation, we will get this final equation, and this equation will show that this relationship, that is molar mass of solute, that is M2, and its relation with relative lowering of vapor pressure, that is delta P upon P10. So this is the relationship between what we can say molar mass of solute and vapor pressure lowering, that is relative lowering of vapor pressure. So this question may be asked for 2 marks in your theory exam. You should be prepared, and some numericals are also present on this final equation. So this is the all points what we have cleared in our today's lecture. In continuation with this point, we will make new videos in the new session. So you just go on subscribing this channel, you just like the videos and press the bell icon for more videos and updates. Thank you very much.